So in this problem, we solve the rational inequality given there, and it is not in a standard form. So we first get it into the standard form, which means the right hand side must be 0. So we subtract both sides with that right hand side quantity, which would be x over x squared plus 2x minus 3, and then we get the right hand side 0 nicely. So denominator, we have a common denominator now, x squared plus 2x minus 3, numerator 3 minus x greater than 0. So now we can start working from here. Step 1, we set the numerator to 0. So numerator, set it to 0 and get the x value. 3 minus x equal to 0. So you get x equal to 3, one value coming from the numerator, which we may or may not be able to use. We'll check. And coming from the denominator, you cannot use them because denominator 0 would mean things will blow up. But for calculations, we can set the denominator equal to 0 and figure out where all things blow up. So here is a factoring situation. So this would be x plus 3 times x minus 1 equal to 0. So this gives me two values of x equal to negative 3 and x equal to positive 1. And you're not going to use either one of them. So I'll say don't use on that and don't use on the one below. So even if you are in the, you can see that it's a greater than or equal to, I'm sorry, I made a mistake here. Okay. Even if there is a equal symbol there, yeah, if x equal to 1 or x equal to 3 comes about, you cannot use them because they are obtained from the denominator. Okay. That's the thing you need to remember. So now let's draw the x line and mark those values. The values are negative 3 right here, and we cannot use them, so I put a circle around it, and positive 1, and I cannot use them either. I put a circle around it, and positive 3. I don't know if I can use or not, so I'll leave it as it is. So to the left of negative 3, I can choose a negative 4. And in the middle, I can choose a 0. And the second part, one between 1 and 3, I can choose a 2. And to the very end, I can choose a 4. So with these, I can double check whether they all work out or not. That's where we are at. And 3, another one. So let's see, if I plug in negative 4 into my equation, that is 3 minus x, so it will be minus of minus 4 divided by, I have a factoring, negative 4 plus 3 times negative 4 minus 1. Now I'm not interested in the precise value, I'm only interested in the sign. So the numerator is positive, so 3 plus 4. Denominator, one of them is negative, both of them are negative, so negative 1 times negative 4, 5. So this overall comes to positive value, so which is greater than or equal to 0. And now plugging in 0 will give me 3 minus 0 over all the x's goes to 0. Here we go. This is negative 1, which is less than 0. And positive, this is the condition we want to satisfy, which is greater than or equal to 0. So the first group satisfies, second group doesn't satisfy. Now the third group, where we pick 2, so that'll be 3 minus 2 over 2 plus 3 times 2 minus 1, which is 1 over 5 times positive 1, which is 5. It is positive, i.e. greater than or equal to 0. We like this guy. Okay, now go to 4. That means check mark. Now 4, let us plug in 4. We get 3 minus 4 in the top, divided by 4 plus 3 and 4 minus 1 in the bottom. Overall, this gives me negative. So less than 0, I don't need that. So my answer should be in this domain, in this range, in this domain where minus infinity up to minus 3, where I cannot use minus 3, and 1 up to 3. Can we use 3? Now that bigger question is, can we apply 3? So special case, we come down here. If we apply 3, 3 minus 3 goes to 0 in the numerator divided by something in the denominator. I know that it's not going to go to 0. So numerator alone that drives the whole thing and it goes to 0. And that is allowed because the greater than or equal to symbol will use allow that go through. So we have minus infinity up to minus 3, all open interval, and open from 1 up to 3, 3 is closed. So let us see if Hawks accepts this as the answer. Minus 3 there, and then union. No, we cannot use that parenthesis. We can open on left, close on right, which would be 1, comma 3. Yes, it worked.